Good day, learners. Welcome to Technical Mathematics lesson. My name is Mathulela Takomu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Welcome, grade 11s. Today's topic is Euclidean geometry, and we're gonna look at circle geometry. Lesson objectives. At the end of this lesson, learners must be able to describe and identify and describe parts of circles and apply the first 4 theorems. And so far, I guess you have done the first 4 theorems. And we have to interpretation of those theorems. You need to be able to interpret them. Okay, let's look at our parts of circle. So we know that in a circle we have to look for the radius, and we know that the radius is a line from center to any point on the circumference of a circle. So we know we have our center there, and the radius is just the part that moves from the center to any point of the circle. The second one, we have a diameter. A diameter is a line passing through the center of the circle. It is double the length of the radius. So when we're speaking about our diameter, we're speaking about the line that is moving from the other side of the circle, passing through the diameter to the next part of the circle. It must pass through the center and is touching the circle 2 times. Then from there we have a chord. A chord is a line with endpoints on the circumference, but a chord, it doesn't cut the circle. It's only touching the circle on 2 points and is not going through the center. You have a chord. It's touching the circle 2 times and is not going through the center. So we have what we call a tangent. With a tangent, it's a line touching the circle at any point, any one point. So here we have a point and a line that is touching a circle at that point. We call it a diameter. And a line that is touching a circle at one point, we call it a tangent. Sorry, not a diameter, it's a tangent. Correct. So now we have also what we call a secant. A secant now, it's a line that is cutting through the circle. It's just passing through the circle. It's cutting the circle twice. It doesn't touch, it cuts through the circle. So that's what we call it a secant. Then now, on the part of the circle, we have what we call a sector. You know a sector. It's like a slice of a pizza. When you buy pizza, you see that your pizza will have a shape of a sector. Then now we also have what we call a segment. A segment is just that piece of part there of a circle. Then you know we have also an arc. It's an integration from EGD. Those who are doing EGD now, they will know what is an arc. When we're talking about an arc, then this is an arc of a circle. So when we now know and understand our parts of circle, we can now go to our first theorem statement. So our theorem statement is stated: the line drawn from the center of a circle perpendicular to a chord bisect the chord. So now we are talking about a line drawn from the center of a circle. perpendicular to a chord, it bisects the chord. So what are we talking about here? We have a center 0. So a line that is drawn from the center of the circle to the chord, and it is perpendicular to the chord. We're saying that line does what to the chord? It bisects the chord. You know, when you bisect the chord, it means you cut something into two equal parts. That's why you saying we bisect. So now, the reason for this theorem, when you have to give a statement for this theorem, the reason it will be line from center perpendicular to chord. It's going to be the line from center perpendicular to chord. So now we're saying if RO is perpendicular to PQ, then we can say RP is equal to RQ. That is the first theorem statement there in theorem 1. Then we go to the very same theorem 1, but with another alternative, or we can call it a converse. Then the theorem states as follows: the line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. So now we're talking about a line that is drawn from the center of a circle to the midpoint of a chord. So now we can see that we are having our center as O. The line is drawn to the midpoint of a chord. So why are we saying to the midpoint of a chord? Already you can see that the distance from A to C and the distance from C to B, they are indicated that those lines are equal. So when we're using this type of a theorem, you state the reason as the line from center to midpoint of a chord. That's how you state the reason. Line from center to midpoint of chord. Then what do we say? We're saying if AC is equal to CB, that is your chord, then OC, it will be perpendicular to AB. And remember, when we're talking about perpendicular, we're talking about the angle of 90 degrees. The angle of 90 degrees. That's why we're talking about perpendicular line. Okay. Now, let's look at our first activity and let's apply what we know about the first theorem. So, the question is as follows. O is the center. AC is equal to 8. OB is equal to 3. And OB is perpendicular to AC. That is the statement that is given. Then the question says, calculate with reasons the length of AC and OC. I'm supposed to say the length of AB and OC. So now, looking at the statement there, it is given that the length from A to C is 8 units. Then now we have to calculate the length of AB. It means the length of AB, half of that length. We need to calculate it. Then now we know that if OB, it is perpendicular to AC, then we know that AB, it will be equal to BC. How to get? So now we're going to say, therefore, AB is equal to 4. Because if you say 4 plus 4, then you get 8. It means you get 4 there. Then what will be the reason for this? Remember, The reason will be line from center perpendicular to chord. That will be your reason. Line from center perpendicular to chord. Because we said if the line from center is perpendicular to the chord, then it bisects the chord. Correct. So you know when you bisect, you divide into 2 equal parts. It means that 8, you divide it by 2, it will be 4. So each length there from AB to BC, it will be 4. So that is how you prove that those 2 lines are equal, AB and BC. It is as simple as that. So now you move to the B. The statement still stays the same, that O is the center, AC is equal to 8, OB is equal to 3, and OB is perpendicular to AC. But now we know from the previous slide that AB is equal to 4 and BC is equal to 4. The length of BC there is equal to 4. Then now we have to calculate with reasons now the length of OC. Then if you can look at the length of OC there is the length of the radius. Correct. So how are we going to calculate the length of BC? I mean the length of OC. You can see that we have a triangle there, and we must identify that type of a triangle. We know that it's a right angle triangle because it has one angle of 90 degrees there. That's when we concluded that it's a right angle triangle. And the minute you have a right angle triangle with 2 sides that are given, and you have one unknown side, you know that for you to calculate the unknown side, you must use what we call theorem of Pythagoras, or Pythagoras theorem. Then now, how do we use Pythagoras theorem? We're looking at the longest side of the triangle, which is an hypotenuse side. Then we're going to say OC squared is equal to OB squared plus BC squared. Then remember, this is your Pythagoras theorem. Correct? Then now you look at what is given or what you have. We have the length of OB, which is 3. And we also have the length of BC, which is 4. Then you substitute there. OC squared is going to be, we know that the length of B we substitute by 3, OB we substitute by 3, and BC we substitute by 4. Then now you will go and punch in your calculator that 3 squared is equal to 9 and 4 squared is equal to 16. Then your OC squared is going to be 25 because 9 plus 16 is 25. Then we're not looking for OC squared, we're looking for OC. Then that's where now you will do what? You will introduce the square root both sides. Remember, the square root will cancel your exponent of 2 there. So therefore your OC is going to be 5. So the length of OC there is going to be 5. The length of the radius. Remember, OC is a radius. So this is how you use this type of theorem, or how you apply this type of theorem. Correct? Then now, let's look at the second activity. The question says, calculate with reasons the length of WR. We must calculate the length of WR. Looking at our sketch, we know that we have the center of O there, and we have a chord. Remember, WR is our chord. WR is our chord. And then it is given that WT and TR, they are equal. It is given that they are equal. Then when we know that they are equal, we now have to calculate the length of WR. But how do we calculate the length of WR? We must remember our theorem that says if you have a line from center to midpoint of a chord, then it will be perpendicular to the chord. Remember, when you're saying midpoint, it is given that WT and TR are equal. It means this line from O to T is going straight to the midpoint of that line. Then when it's at the midpoint, we know that it is perpendicular to the chord. Then the minute it's perpendicular to the chord, then we can look at the bigger picture, which is our right angle triangle. Correct? Then we know that we have ROT at 90 degrees. Then now, what are we going to see? We're going to start by saying OTR is equal to 90 degrees. Then we have to give it a reason. The reason will be what? The reason will be line from center to the midpoint of your chord. That's where now you get your mark. To identify or to prove that that triangle there is a right angle triangle first, before you can continue with your question. Correct. So now we have proven that that triangle PTR is a right angle triangle. And we are given the length of RP and we are given the length of TP. Remember, our aim is to calculate the length of WR. But for us to get WR, we must firstly look for what? For TR. We must firstly look for TR. Then how am I going to do that? We are going to use a Pythagoras theorem because we are having a right angle triangle there. Then we're going to say our hypotenuse, remember, is RP squared. Then we can have our TR squared plus our TP squared. Then we know when we substitute that our RP is 9,47 squared. Then we are looking for TR. We don't know what is TR. We are looking for it. But your TP, you know that is 8,43 squared. That's where now you substitute. And remember, always when you substitute, you must substitute using your brackets there, inside the bracket. Then now, from there, you will have to use your calculator to get what is 9,7 squared. 9,7 squared. Then it's going to be 86,68. Then you will have to punch again your 8,43 squared. 8,43 squared. Then here you're going to get 71,06. You will get 71,06. So from this one, you know that you will have to transpose this 79,16 to the left-hand side. And the minute you transpose it, then what are we going to get? We are going to get that 81 minus, because it's going to be minus there. There's 86, 68 minus 71, 06. Then we're going to have 15,26. It's equal to TR squared. Then you introduce the square root both sides. Therefore, your TR is going to be the square root of 15,62 let's see, 68, 4 squared 9, okay, sorry, 9,4 is not 86, is 89. So what about that one? Is 89. Then now, when you transpose, you are going to say 89 minus 71, 06. Then that's where you will have 18,62. Then it's equal to TR squared. So what about that one? Then now you will have the square root of 18, the square root of 18,62. Then we're going to have 4,32. Then that's how we calculate that one. So what about that? Now, let's move forward, and this is how you answer this type of a question. Remember, the first thing that we needed to identify is our 90 degrees angle there for it to be right angle triangle. And the reason was the line from center to midpoint of a chord is perpendicular to a chord. How to get? Then from there, we used theorem of Pythagoras to calculate the length of RT. Then when you get your length of RT, remember the question says we must calculate the length of WR. Then the length of WR is going to be 2 times 4,32. Then of which you are going to get 8,64. That is the length of WR. That's how you get your length of WR. So those are the steps that you need to follow for you to get that length of WR. Then let's look at our theorem 2. Then in theorem number 2, the statement says, theorem statement, the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circle on the same side of the chord as the circle. How to get? So now we have the reason for that. Remember, when you give a reason, you need to shorten it up. It will say the angle at center is equal to 2 times the angle at circumference. That's what theorem 2 basically means. Then you have the 3 ways where we can identify that angle at center is twice the angle at the circumference. So the first one, remember, we are having the angle at the circumference, which is x, and the angle at center is going to be 2x. Correct? So now, you look at the first diagram, we had something like that. Correct? Now, it's moved to A like that so that you can see it that way. So basically, it's the same thing. You see it moves from here, then they just direct it to A. So this angle here is the angle at the circumference, which is x. And the angle at center is going to be 2x. So that's what they have done basically in this theorem. This angle here at the circumference is still twice the angle at center. So now, looking at the scenario number 3, we are given the angle there at center, which is twice the angle that is there by the circumference. So you will have 3 scenarios when they are asking this type of a question. You need to analyze all these 3 scenarios and see which one will be suitable for the type of question that you will be asked. Let's see how do we now apply this type of a theorem. The first one says O is the center, okay? Calculate the sizes of x and y. Then remember, on the first case, we have the circle with the point A, B, and C, and O is the center. Then now, the angle now that is given there at center is 130. And we have the unknown variable there by the circumference at C, which is x. Then we need to calculate for that angle there. Then we have to write the statement for this question. Our statement is going to be, remember we said angle at center is 2 times the angle at the circumference. It means the angle at center is just O. But the angle at the circumference, it's C, but is twice the angle at center. Hence we said 2 of C is equal to O. Then the reason here, it will be what? The reason will be angle at center is equal to 2 times the angle at the circumference. Then you will have a mark for your theorem and a statement. Then now, how do we get now x? We're going to have 2 of x. Now we are substituting. The angle there at C is x. Then it's equal to 130. Then the minute you divide both sides by 2, 2 will cancel 2. Therefore, x is going to be 65. Correct. So that's how you calculate for the angle of x. Remember, it's basic. Angle at center is twice the angle at the circumference. So now looking at the second one, the same scenario now, we are having the angle at center, which is 50, and we have our unknown angle there at the circumference, which is y. Then how are we going to calculate for y? We apply the very same theorem, where we're saying 2 of your angle C is equal to angle O, the angle that is at center. Then basically you know that the reason will be the same, which is going to be what? The reason is the same as the one that you have given there at the first question. Angle at center is twice the angle at the circumference. So how do we get your angle now? Remember, it's 2 of what? We are looking for y now, but the angle of center is 50 degrees. Then for you to get y, you will divide both sides by what? By 2. 2 will cancel 2, then your y is going to be what? 25 degrees. So that's how you use that theorem. Angle at center is twice the angle at the circumference. So looking at the very same theorem, but now we are given the angles at the circumference and we have to determine the angle at center. Now, the question says O is the center. Calculate the sizes of x and y. Looking at the first one, you can see that unknown now is at the center. The angle at center, we don't know it. It's unknown, it's x. But the angle at the circumference, we know it, which is 62. Then how do we get the value of x? Then we start by saying angle at center, which is C, it's equal to the angle at the circumference, which is O there. It's your ABO, correct? Then now, the reason, remember, is going to be angle at center. It's equal to 2 times the angle at the circumference. Correct? Then now we know what is the angle at the circumference. The angle at the circumference is what? 62. Then the angle at center is x. Therefore, your x is going to be 62 times 2, which is going to give you 124 degrees. So that's how you get the angle at the center. Remember, the angle at the center, it should be bigger than the angle at the circumference. It's 2 times the angle at the circumference. How to get? So now we go and look at the second one. The second one now, we still have the very same scenario whereby the angle at the circumference is given as 23 and the angle at center is y. It's unknown. Then it's going to be 2c, it's equal to angle O. And the reason is the same as that one of angle at center is twice the angle at the circumference. Then now we're going to have 2 of 23 degrees, it's equal to y. Therefore, your y is going to be 46 degrees. So that's how basically we calculate this type of angles. Remember, sometimes they can give you the angle at the circumference and ask you for the angle at center, or they give you the angle at center and say what is the angle at the circumference. So now, let's look at how can we now apply this type of theorems in this situation. Remember now, it will not be a straightforward question like the past 2 activities. This one we have to analyze it and get x and get y. So O is the center of the circle. Calculate the sizes of x and y. Then you can see that now I have the unknown at x and I have the unknown at y. At x and at y I have the unknown. Correct? But I have to get the size of x and get the size of y. But now, what is it that is given? Is angle Q there? Angle Q is given inside the circle. I mean the triangle PQO. But now, what do I know about that type of a triangle? We have a triangle, we have O, we have P, we have Q, we have R. Then now, we have to go and say, okay, in this triangle, what is it that I know? I know that your OQ and OP are equal. OQ is equal to OP. You know that they are equal because they are both radius. Then the reason for that, you will say, is radii. Both radius radii is the correct reason to give there. Then when you have your OP and OQ as a radius, we now know that the triangle OPQ, it's an isosceles triangle. It's an isosceles triangle. What do we know about isosceles triangle? Isosceles triangle, it has 2 equal sides and 2 equal base angle. Now, how do I get x? I know that my P is going to be 70 degrees as well. But we need to give a reason. Why are we saying P is 70 degrees? Remember, angle OPQ is equal to angle OQP. They are both 70 degrees. But what is the reason, the proper reason for that? Most of the learners, they will say it's the base angle of an isosceles, correct? Of which is not the correct statement to give in this case. Yes, it's true that it's a base angle of an isosceles triangle. But the correct statement that you have to give there, it's angles equal opposite angles is angles. The right reason is angles opposite equal sides. That is the proper reasons to give there. Angles opposite equal sides. Remember, the angle here and the angle here, they are both 70. Why are we saying they are both 70? Because of they are opposite equal sides. How to get? So there is the proper reason to give when we are dealing with the isosceles triangle. It's opposite, angles opposite equal sides. When you want to prove that angles are equal. Then from there, you can see that if now our P is 70, we can get our angle of X. How can we get the angle of X? You know that OPQ, it's a triangle. And we have two angles inside the triangle, but one is unknown. Then from there, we're going to see what? We add X plus 70 degrees plus 70 degrees, it's equal to 180. That is the statement. What will be the reason? Angles in a triangle, or sum of angles in a triangles. You can say sum of angles in a triangle or angles in a triangle. They add up to 180 degrees. Then what will be your X? Your X will be 180 minus 1 foot. Then, therefore, X is going to be foot. Correct? Now we know what is the value or the size of X. It's foot degrees. Then now, after getting X, we still need to calculate for Y. So now, you can see that from the diagram there, we have a picture like this. Now we talk about the second theorem. Angle at center is 2 times the angle at the circumference. That's where now we are coming from. So we're going to have what? We're going to have 2 of y, it's equal to x. Then this is angle at center. Angle at center, it's equal to 2 times angle at circumference. Correct. So now, 2 of y is equal to foot. We divide both sides by 2. Therefore, your y is going to be what? 20 degrees. So, this is how we calculate the length of, the sizes of x and y, following the statement together with reasons. Following the statement together with reasons. So, for each and every statement that you put there, you must give a reason for it, so that it makes sense when we answer this type of a question. So you can see that this type of a question, there are certain applications that needed to be performed before we can get to our answers. So always you need to analyze your diagrams. Okay? Now, let's look at our third theorem statement. It says the angle subtended by the diameter at the circumference of a circle is 90 degrees. So the reason there, we're going to say it's angles in a semicircle. Angles in a semicircle. So here basically they say if AB is a diameter, then your angle C, it must be 90 degrees. If AB is a diameter, then angle C, it will be 90 degrees. Then we can also look into the theorem 2. We're going to say this angle here, we know that is 90 degrees, 1/8. The angle there at center is 1/8. And the angle here at the circumference is going to be 90. But now we are given the diameter, and the angle subtended by that is going to be 90 degrees. Angles in a semicircle. Then now, let's see how do we then apply this type of a theorem. O is the center. Calculate the size of x. Now, looking at this type of a diagram, we can see that our AC is passing through the center. It is a diameter. Our AC is our diameter. And we know that the angle there that is subtended by the diameter is going to be 90 degrees. It means the whole of B is 90 degrees. Then we're going to say what? A, B, C. We are talking about angle B now. A, B, C. Your angle B, that is what we are talking about, is equal to 90 degrees. Then the reason will be what? Angles in a semicircle. Angles in a semicircle. Correct. Angles in a semicircle. Now, angles in a semicircle is equal to 90 degrees. What does it mean? It means if I add x plus 52, I must get 90 degrees. If you add x and 62, you must get 90 degrees because the whole of that angle B is 90 degrees. Then from there, it's easier for us to calculate x because the equation is already there. How do you calculate for x? We just transpose x to the right-hand side. Therefore, your x is going to be 90 minus 52. Then your 90 minus 52, it will give you x as what? 90 minus 52, which is going to be 38. 38 is going to be your answer. So this is how you apply this type of a theorem. You firstly identify the angle of 90 degrees there. Then from there you can deal with what is given there in the diagram. Okay? We have another case here. O is the center. Calculate the size of x. Now, PR, it is the diameter. And if PR is a diameter, the first thing that we need to identify there is this angle Q, which is what? Which is 90 degrees. It is given. Angle subtended by the diameter at the circumference, it will be 90 degrees. Then now, we have to specify that angle Q is 90 degrees. That's where you get your first mark. Angle Q is 90 degrees. Angles in a semicircle. circle. Angles in a semicircle. That's where you get your mark. Sometimes you will find that you get the mark for statement and reason. Already you have 2 marks when you answer that type of a question. Before I can even get the value of x. Then how am I going to get the value of x? Remember, I am having a triangle there. I know the first angle there is 90. 55 degrees is given. I now want the value of x. So it will be basically angle P plus angle Q plus angle R is equal to 180 degrees. Remember, those are sum of angles in a triangle. You give a statement. Angles in a triangle. Then now, what is angle P? It's 55. What is angle Q? It's 90 degrees. R is x. Then 180. Then you know that you are going to add the 2 and transpose them to the right hand side. Then your x is going to be 180 minus 90 minus 55. Then now you will use your calculator to get the value of x. What will be the value of x? If you say 180 minus 90 and minus 55, we are going to get 35. Correct? So now you see that for you to calculate x, there was a certain theorem that you needed to perform, or a certain step that you needed to perform, which is to get that 90 degrees there. Correct. So now we go to our theorem 4, then it states as follows. Angle subtended by a chord or arc of the circle on the same side of the chord are equal. So now we have our chord there, or we can say we have our arc there. Those angles that are subtended by the same arc or chord, they will be equal. So here we want to say your angle A is equal to angle C. Then the reason, how do we reason with this one? We are going to say what? We are going to say angles in the same segment. That's how you will reason on that one. Angles in the same segment. Okay. Now, we are having other conditions of the very same theorem. Then, remember, here we said angles subtended by an arc or a chord. They are the same. Correct? Now, we still have 3 conditions of the very same theorem. Remember, the first one, it says equal chords subtend equal angle at the circumference. If you have a chord in the 2 separate triangles and those chords are equal, they subtend the equal angles. So you give a reason to this, you will say equal chord equal angles. Equal chords equal angles. That's how you're going to give the reason on that one. Correct. So now, the very same theorem, it comes and say equal chord subtends equal angles at the center. It means if you have the equal chords at the circumference, they will subtend the equal angles at center. The third one now, it will say equal chords of equal circles subtend equal angles at the circumference. So now, here we are having two circles that are equal. You can see there we have the first circle there, and we also have another circle there. We have two circles. Correct. So now those two circles, they are equal. It's given that the two circles are equal. Equal chords of equal circles subtend equal angles. So this chord here is on circle 1, and the other chord there is on circle 2 or in circle 2. But those chords are equal. Then they will subtend equal angles in those two circles that are the same. So, given the reason for this theorem, you will say equal chord, equal circles, then equal angles. You will state your equal chord, equal circle, and equal angles. That's how you will state the reason for those angles. So, from there, let's now look into our diagram there. Activity number 5, it says, A, calculate the size of x and y. You can see there. I used to call this type of a theorem a butterfly. Remember, your butterfly will look like this. You'll have a butterfly like that. That is a butterfly. But in a butterfly, we know that that angle and that angle are equal, and that angle and that angle are equal. You must look for a shape of a butterfly when you're dealing with this type of a theorem. So now, you know that this angle here will be equal to that angle there, subtended by the same arc EF. Then we're going to say x is equal to 18 degrees, not 180, 18 degrees. The reason will be angles in the same segment. The very same thing that will apply there in y, we have the angle that is unknown, y, and we have the angle of 22 there. Then the arc of HG or GH subtend those equal angles there. So we are going to have y is equal to 22 degrees, then angles in the same segment. That's how you are going to apply that type of a theorem. Simple as ABC. Easy to apply. You just look into the shape of a butterfly like I said. Are we together? So now, let's look into another activity. In this activity, you can see now the diagram looks a little bit complicated, but the same thing that we need to apply. Calculate the sizes of x, y, and z. Correct? Looking at this diagram, you can see the first one for us to get x, we know we're looking at this arc here, the arc of BD. Subtend those two equal angles, A and F. So x is going to be 32 degrees, correct? Then now the reason will be angles in the same segment, correct? First, free 2 marks. You have identified the butterfly. I told you about butterfly, correct? Then now let's check. We analyze the diagram. You can see that I have a triangle like this. And there is nothing, there is something that I can identify from that triangle. And by the way, we have so many ways to deal with this type of equation. But looking at the triangle that is given there, we have a line that is going out like that. Then we know that if we have a triangle and a line that is going like that, is extended to A. This line here, this angle here of Z, it's equal to the angle of A and the angle of C. Then we know that we call that the exterior angle of a triangle. The exterior angle. Remember, you were taught that if you see something like this, then you will say, this is your exterior angle. That is your exterior angle. And exterior angle is equal to 2 opposite interior angle. It's equal to 2 opposite interior angle. That's what I have applied here, or I'm about to apply there. Correct. So that's basically how you have to analyze your diagrams. Hence, I said there are so many ways to answer this type of a question. One could have said, no, I know that now my x is 32. I am having another type of a triangle that I can work with. Correct. I am having another triangle that I can work with. Having your y as a exterior angle of a triangle. You see now the blue triangle that I've drawn there, it's now give you the exterior angle of a triangle. Remember, y is an exterior angle of a triangle, and x we know that is 32. So for you to get y, we can simply say y is equal to 32, which was the value of x, plus c, which is what? 43. 32 plus 43, then you will say now it's what? Exterior angle of a triangle. That's how you will give your reasons there. It's an exterior angle of a triangle. Then what will be the value of y? If you say 43 plus 32, you are going to get your nice 75 degrees there. So that's when we say we analyze this type of diagrams. You must analyze the diagrams. Then now, from here, it's given that your y now is 75. We know what is y. Y is 75. So since y is 75, you know that your y and your z are angles subtended by the same arc, which is AF. Remember, we're having a butterfly there. We're having a butterfly there. So now it means your Z is going to be 75 degrees. Your Z is going to be 75 degrees. Now it's going to be what? Angles in the same segment. So that's basically how you answer this type of questions. You need to be able to analyze your diagrams. Not always will have a one-way answer, like we have calculated x, where we just identify that x is equal to 32 angles in the same segment. Some of the angles we need to apply the knowledge that we have learned in grade 10 of the exterior angles of a triangle, angles on a straight line, angles in a triangle, that types of theorems, we need to know them from lower grades. Okay? Now, let's now look into activity 5. Activity 5, you still in C. There we say calculate the size of x. Calculate the size of x. Then how are we going to calculate the size of x? Remember, we are having two types of triangle there. Correct? And the other part of a triangle is that one. Right. But those triangles, they are subtended by equal chords. AB, chord of AB is equal to the chord of BC. Then now we can easily say x is equal to 15 degrees. Correct. It's equal to 15 degrees. Then what will be now the reason? The reason will be what? Equal chords, and equal angles. Then you get your 2 marks then, if it's 2 marks. Statement and a reason. It's as easy like that. So now let's look into activity 5D now. We read the statement, and as we read the statement, it will be very important for us to note what they are saying on the statement. Hence, every time we are advised to read the statement carefully and we apply what we know. The statement reads as follows. 2 equal circles are given. Note that 2 equal circles are given. Those circles are equal. Correct. O is the center of circle ABE. O is the center of circle ABE. Calculate with reasons the size, the value of x. We must calculate this value of x. Now, we need to interpret or analyze. We need to analyze actually our diagram. And how are we going to analyze our diagram? Look at what is given there on the diagram. It is given that the chord of AB and the chord of DC are equal. Correct? It's tick. That's what we know. It's given. What is given again is given that angle O there, the angle at the center there, AOB, it's equal to 120 degrees. Then now, how are we going to arrive to a conclusion that x is, how are we going to arrive at the conclusion that we get the value of x? What is it that we need to do first? Now, remember, this chord AB and this chord DC, they are subtending the equal angles there at the chord. It means this angle of E1 and this angle of X, they are equal, those angles, because it's equal circles, equal chords, and equal angles. You remember the third condition there of theorem 4. The third condition, we said, when we have two circles that are equal, with the equal chords inside those two circles, then it will subtend the equal angles there. But now we don't know what is E1. Therefore, we can't get our X. But we can get our E1. Looking at theorem number 2. Remember our theorem number 2. Angle at center is 2 times the angle at the circumference. It means for us to get E1, correct? For us to get E1, we must say 2 of E1 is equal to angle O there at center. Then the reason is going to be what? Angle at center is equal to 2 times the angle at the circumference. Correct. Then from there, we know 2 of E1 is going to be 120. Then we divide both sides by 2. 2 will cancel 2. Therefore, angle E1 is going to be 60 degrees. Now we know what is our E1. 60 degrees. Then from E1, how do we get our X? We go to the very same theorem that I spoke about. Equal angles, equal chords, equal circles. Then we'll say, okay, therefore it means my angle X is equal to angle E1 and they are both equal to 60. So your angle X is going to be 60 degrees. But now, what is going to be the reason for that? The reason is going to be equal circles having equal chord, equal angles having equal chords, then you're going to have equal angles. So that's how you interpret and solve that type of equation there. So you see that for us to get X, we can't just go straight and solve for X. We need to perform other theorems before we can get there, according to how the diagram is given. So this is how you solve these particular questions. And this is the end of our lesson. And remember, we learn by repetition. You repeat these theorems over and over again for you to understand them. Thank you.